What's it about? Raking leaves. That's probably all you got the first time around. Maybe you know that we need to do a table, there's a graph in there, but that's all you're supposed to get the first time through. Now let's go through and highlight the key information. In that first main sentence, what's important? Every bag, $10. In the grand scheme, do we care that it's leaves? No, you could be bagging dog poo, you could be bagging grass. Anyone want to come to my house and bag some dog poo? Just saying, I'll pay you. Pay you? No. That's all we care. We care for every single bag is $10. We don't care what's in the bag. Part A. Keywords, part A. Table. 1 through 8. Okay. Some people like the action word, which is create, so it tells you what you're doing. Okay. So we know for part A we're going to make a table. Part B. Variable, independent, dependent. So you've probably heard those in science before, independent, dependent variables. We'll talk about it once we get to part B. Part C, what are we doing? Create a graph. Part D. Create an equation. P for and B for bags. So 2 days ago when we started this, I said don't get too caught up in those variables. They're just variables. So what this has done is given you. They've said to you you're going to use B and P. E. How much? Earn 5.5 bags. And the last one. How much? Earn 12 bags. Okay, so let's go back to part A. Don't let the rest of you stress it out yet. I'm going to do a vertical table this time just because when we did this a couple days ago, I was doing them all horizontally. If you still like horizontally, there's nothing wrong with that. I'm just mixing it up. What are the two things going to be on our table? Number of bags. Money. The question has specified 1 through 8. One bag, how much will you earn? 10. That means 2 bags will give you 3 bags. Next value. That's all part A is asking, make the table. So just like we did 2 days ago, except you had to do a little bit of calculation. Part B, what is the independent, what is dependent? What does that mean? So probably way back in science you've heard these terms before. What does that mean, independent and dependent? Have you heard the terms before? Never heard the term. Okay, so let me start from scratch. Remember 2 days ago I told you math is all about patterns, right? And that's what scientists and mathematicians do is we try to find patterns, and once we have a pattern, we try to describe it. So for your world, everything's going to be linear. This is a linear pattern. Next year, when you go on to whatever level of math, there'll be other kinds of patterns. So when we look at patterns, we look at what's the cause, what's the effect. So independent is what you can control. Dependent is what happens because of that. So what can you control? The amount of bags that you rake or the amount of money that your dad's going to give you? The amount of bags. That's what's in your control because you're physically going out and raking it. Can you control the amount of money? No, your dad's going to give you $10 a bag. That's already set out. So we would say that the independent and we use IND to abbreviate independent, would be the number of bags. And that would make the dependent, and we use DEP for dependent, would be the money. So describing my red pen just to make some notes about that. The independent variable is what you control. The dependent is what we call the effect of that variable. So because you raked, what happens? You get money. If your dad just gives you money for no reason, is that going to make you go out and want to rake leaves? No, right? Because it doesn't have that kind of effect. So it's the effect of breaking the leaves. In terms of just a generic graph, so here's our xy axes, the independent variable is always x, goes along the bottom of the graph. What goes along the side or the y-axis? The dependent. Okay, so that's why this question has asked you to identify them. It's to help you know what's going to go on the bottom versus what's going to go on the side. Okay, part C, let's make a graph. We use rulers to make graphs. We're not barbarians. So on a test, if you have little scraggly line graphs, I'm not marking them. If you don't have a ruler, there's always a box at the front of my room, or you can use the side of your calculator, the side of the book, the side of a piece of paper. But we make graphs with nice straight lines. What is going on the bottom or the x-axis? Is it number of bags or the amount of money you earned, and how do you know? Why? It's the independent variable. Independent always goes along the bottom. What scale would you like to use? So what's the least number of bags? What's the most number of bags? So what's the least number of bags you could break? 0. You could choose to do none. Look at our data table. What's the highest amount of bags? Good morning.
Sorry for interrupting. Emma McAllister, is it okay if she came to the office for a moment?
Does she need her stuff or just her?
Oh, just yours, good, thank you.
Okie dokie. What did you do? Okay. What's the most amount of bags we have on our table of values? So do you want to jump 1 line, 2 lines, 3 lines? How do you want to space them out? So if we just go 1 line, we're going to end up about here. That's a teeny tiny little graph. So it's probably a good idea to jump 2. So leave a space, put the 1. Leave a space, put the 2. In general, you want your graphs to be about 1/4 of a page. Okay? Anything smaller and it's just too hard for me to see the points. What's going to go on the y-axis or the vertical axis? What's the least amount of money you can earn? Look at our data table. What's the highest amount of money you can earn? What do you want to jump by? Yeah, 2 sounds good because we did that on the other one. Again, you want your graph to be roughly 1/4 of a page. If you're doing little teeny tiny graphs, they're just too hard for me to see. If you're taking up a full page, you're just wasting paper. About 1/4 of a page per graph. Okay, we got the axes labeled. We got our scale. What do we do now? Put in some dots. So 1 bag, how much? What is the shape of the graph? A line. If it's not a line, you've done something wrong, because everything we're going to do this year is always going to be linear relations. So if you graph and you get something freaky, something's gone terribly wrong. Okay, there's what a proper graph looks like. The axes are labeled with their units. It's about 1/4 of a page. It's done with a ruler, and it's nice and neat. Part D is that equation stuff that we did 2 days ago, so I'm just going to refresh. We have this general equation that says y equals mx plus b. And remember I said that's going to come back more next year, so don't get too caught up on what it means. We know that we have to put a number in for m and a number in for b. X and y just remain as variables. Well, the reason it's x and y is because this one refers to the y-axis. And guess what the x refers to? The x-axis. So whatever it is you have on the y-axis, that's the variable that goes on the left. And the question has given you variables. If it didn't, it's completely your choice, but if it does, you have to use what the question has said. What variable have they given you for the money? P. They've said P for pay, so this is going to be P. I'm going to fill in that m in a second. I'm just going to go to the x. X is the variable that's on the x-axis. Again, if it's not given in the question, you can use whatever you want. Was it given in the question? B, so this is going to be B. Now we just need to fill in those numbers, and it came from the table of values. How do we figure out this m value? Yeah, it was the pattern. So this goes from 10 to 20, 20 to 30, 30 to 40. What's it going up by? 10. How did we figure out this number at the end that we were adding? We don't need it, but just tell me how we figured it out before. We multiplied, and then we added whatever we needed to get this number here. So 1 times 10 is 10. Do I need to add anything? So just for now, I'm going to put plus 0 just to show you why there's no number there. Let's say, for example, this had been 13. What would we have had to add? Plus 3. What if it had been 9? Minus 9, right? Just depending on what the question. So our final formula is P equals 10 times B. There's our equation. Why P and B? Because the question told you to. E wants to know is how much would you earn if you quit raking after 5.5 bags? 2 different ways we can do this. We can go to the graph and use interpolation, or we can use the equation, completely your choice. I'm going to use the equation for this one, and I'll show you in a second how to do the graph. So we're taking out B, and what are we putting in its place? 5.5. Please don't use your calculator. 10 times 5.5. 55, and we need some units. Dollars. If we wanted to use interpolation, we would go to 5.5, and we go up and over. And what's in between 50 and 60? 55. Your choice, whatever method you want. You can use the equation and use substitution, or you can use the graph and use interpolation. Why did it make sense in this case that we could use interpolation? You could rake partial bags, right? We'd like it if you rake full bags, but hey, you can rake partial bags. F wants to know how much would you earn if you raked all day and filled 12 bags. Again, I'll do it with the formula, then I'll show you on the graph. B is coming out, 12 is going in its place. 10 times 12. Units, dollars. Now this is why the equation's a little bit easier for the graph, because if I wanted to use the graph, what would I have to do here? I'd have to extend it. So 9, 10, 11, 12. I'd have to extend the line. Do you see why we like equations better than graphs? Yeah, we'd have to take this all the way up. I'd have to extend the other one. If we did all that, we would get 120. This is why we like the equations. It just makes it easier than trying to work with the graph. For interpolation, it's not so bad, but for extrapolation, man, it's a little messy. Here's everything we've done in the last 2 days, all combined into one question. Show me your thumb. I'm getting this, I'm kind of getting this, I'm not getting this. Good. Read number 2 to yourself. So just read to read. What's it about? Amusement park, okay? And probably you figured out we have to do some stuff with it. Okay, main sentence, what's important? Flat fee, $20. In the math world, do we care where they're going? No, the amusement park people do, but we don't care if they're going to an amusement park, a movie theater, we don't care. We care about the money. Flat fee of $20 plus $5 per person. Part A, what are the key words? Create a table. Two, 4, 8, 10. Some people want how much to pay, which is fine. Part B. Independent variable and dependent. And again, they're asking you that because it's going to help you get the graph correct, which is what C is, create a graph. D, P for people, C for cost, create an equation. Part E, how much, family of 5. $20 people. Do you see the similarities already between the questions? Guess what? When we draw this graph, I don't want to spoil it, but what kind of graph is it going to be? Cameron. Okay, create a table. I did the last one vertically, so I'll do this one horizontally. Again, it's completely your choice. What are the 2 variables that we're dealing with? Number of people, cost, and the unit for cost is dollars. What are the numbers we need on the top row or the first column if you're doing it vertically? 2, 4, 8, 10. And I just spaced them out so I'd take up the whole table. Okay, 2 people. I'm just going to show the calculation just so when you look back you see how we got the number that's going to go here. So we have to pay the $20, plus we have to pay $5 per person. So how much is $5 per person? $10, and then the 20 is going to make it 30. Okay, 4 people. How much do we have to pay per person? $5. So 5 for 4 people is, plus the flat rate of 20, 40. 8 people, $5 a head is 40, plus the flat rate of $20. 10 people, $5 a person, $50, plus the flat rate of 20, 70. Independent and dependent. You're going to go to the Red River X. What can you control? The amount of people you go with or the amount that you pay when you get to the gate? You control the amount of people. Therefore, the dependent is cost. Again, they're asking you that because it's going to help you set up the graph. That's the purpose they ask you what the variables are. Okay, grab the ruler. We make nice, pretty, neat graphs, not yucky, scraggly graphs. What's going to go on the bottom? Number of people or cost, and how do you know? Number of people, how do you know? Because the independent goes along the bottom. What's the minimum number of people that we could take? 0. Look at our table. What's the highest amount? 10. What would you like to jump by? Choose. Okay. We could have put them one on every line. It's just that would have made the graph a little bit small. Again, roughly how big should your graphs be? About a quarter of a page, right? Too smaller, or if it's smaller than that, it's just too hard for me to read. Bigger than that, you're wasting paper, about a quarter of a page. What would you like to put on the vertical axis or the y-axis? Cost, and the units is dollars. What's the minimum amount of money we could pay? 0. Look at the chart, highest amount. Would you like to write every line or skip and write every second line? Skip, okay. There is a properly labeled graph. Each of the axes are labeled. They have their units. They have a scale, and it's nice and neat. Use a ruler, not scraggly. Now, believe it or not, in exam panic, which we're going to talk about as we get closer to the exam, that's when it's like 2 hours into the exam, it's hot because it's June, the gym smells like the monkey house at the zoo, you really are very tired. I have had people leave it and go on from here thinking they are done. Are you done? Why not? We created a graph. We haven't put the data on it, right? So just because you have the axes set up, you're not done yet. We actually need to put the data. Okay, 2 people, 30. Next one we have was 4, 40. We skipped to 8, 60, and 10, 70. What does the shape of the graph have to be? A line, because that's all we're doing this year. So if it's not a line, guess what? And I think I put a dot in the wrong spot because I don't have a line. What did I miss? 30. D is giving the equation. Again, we start with this general form of y equals mx plus b. M is a number, b is a number, x and y are variables. Y is the variable for the y-axis. Is it given in the question or can we make it up? It's given. What did they give us for cost? C. Do we have a given variable for the x-axis or can we make it up? It's given. What is it? P. Now we just need to fill in the 2 numbers. They come from the chart. So here we jump by 10, here we jump by 20, here we jump by 10. Well, how does that make sense that it's jumping different amounts? Because this is jumping different amounts, and this has to jump by ones. So let's just add in 3 to be able to figure out what we're jumping by. How much would 3 people cost? How much would just the 3 people, just the actual amount per person? 15 plus the 20, so that's 35. So now let's take a look. What are we jumping here when we jump by 1 person? By 5. We'll take a look. That makes sense because how much is every single person? 5. So it makes sense this is going to be 5. So you can't just necessarily look at the table and pick it off. You have to use some thought involved. Okay, what do we have to multiply by to get the value? So 2 times 5 is 10. What do I need to add to get 30? 20. Where does that 20 come from in the question? It's the flat fee. So take a look at our equation. We've actually already used this to calculate the table. It's $5 per person plus flat fee. So we already used it to get the table. That's all the equation is. Party, family of 5. Again, we're just going to use the equation instead of using the graph. If you want to use the graph, we can use the graph. All we're doing is exactly what we did to get the values in the table. We're taking 5 people, timesing by $5 a head, which is 25. Then adding on that 20, the cost is 45. That's all the equation is. It was exactly what we used for the table. Ooh, what about 20 people? So we got to figure out. That is a lot of people. Like a birthday party. Ooh. $5 a head for 20 people. It's like 5 times 2, then add a 0. 100, and then add on our flat fee of 20, cost for 20 people. 120. Show me your thumb. Getting this? Kind of getting this? Not getting this. Good. Find a friend or someone that looks friendly or doesn't even look friendly. You're going to do example 3 together. I'll give you 5 minutes, then we'll talk. Okay, take a look up here. I think I corrected most of the errors that were in the chart. Your graph should end up looking like this. What kind of line is this? Bah! Bah! Horizontal line. General equation is y equals mx plus b. M and b are going to be numbers. Y and x are going to be variables. Are we given a variable for the y-axis, or can we pick it? Okay, what would you like to use for cost? Were we given a variable for the x-axis, or can we pick it? What would you like to use for number of glasses? Now we have to fill in the 2 numbers. Where does the m come from? Okay, what is the table going up by? Nothing. So what do we put for nothing? How do we figure out what this b value is or what we're adding? Is what do we have to multiply, or what do we have to add to get the value in the table? So 1 times 0, 0. How am I going to make that 2? Plus 2. Well, what's anything times 0? So do I need to even write that? No. Equation is c equals 2. Which, think about it, the cost is 2 no matter what. You could have 1,000 glasses, assuming you could drink that much. And how much sugar packages would that be? How much would it cost? $2. Just to note, this is called a constant linear function. What does constant mean? Doesn't change. That's why it's called a constant, because it's $2. Whatever you drink, it's $2.